This video is on section 4.5, covering homework assignment number 28. We're going to be solving exponential equations. In this assignment, you're going to find that all of these equations can be converted to a common base. So when we have an exponential equation, now remember an exponential equation is one that my exponent is the variable and my base is a number. The first thing we're going to do is to try to convert to a common base on each side of the equation, and then once we have the common base, we're going to solve for the variable by setting the exponents equal. Let's look at this. Now you need to remember multiples. Some of these we know, a few we might have to go to our calculator, but we're going to be working with expressions such as 2 squared would be 4, 2 cubed would be 8, 2 to the 4th would be 16, 3 squared would be 9, 3 cubed would be 27, and you'll get comfortable with these as we work with them. Alright, problem number 1. We have a 64 to the x equals 4. Now, here's what you're going to do. To get a common base, you're always going to go to the smaller one or one smaller. In other words, the 64 will not be my new base. I'm going to try to make the 4 my new base. Can you raise 4 to a power and get 64? Well, if you're not sure on any of these, all you've got to do is take your calculator. You're going to go 4 raised to the 2nd. Well, that's 16. 4 raised to the 3rd. That's 64. So this is 4 raised to the 3rd. And you notice that x is also in the exponent. Now, once you do this, you see that the 4's are the base, so I'm not going to use those anymore. I'm going to set an equation with my exponent. So that's 3x equals 1. 1 is the understood exponent of 4. Solve for x. X would be equal 1/3. Alright, number 2. 4 to the negative 3x equals 32. Now I'll try the lowest base, which is 4. Can you raise 4 to a power and get 32? Well, 4 squared is 16. 4 cubed is 64. So you see that will not work. Now what would 4 and 32 have in common? It would be a 2. So I'm going to use a base 2. Now 2 raised to the 5th power is 32. 2 raised to the 2nd power is my 4, and I have a negative 3 exponent there. Now you remember, if your exponent has an exponent, you're going to multiply that. So I'm ending up with 2 to the negative 6x equals 2 to the 5th. Now once I have the same base, I ignore that. My equation is negative 6x equals 5, or x equals 5 over negative 6. Alright, when you get to number 3, we have a base of 125 and 25. We'll try our smallest one. 25 raised to the 2nd power is 625. So you see that's too large. I can use a 5 for each of these. So you try the smaller base. If that will not work, you go smaller. 5 squared is 25. 5 cubed is 125, and I need the x that's still in the exponent. Now, drop your bases. Your equation is 3x equals 2, or x equals 2/3. Alright. Problem number 4. We have a 7 and a 49. 7 can be my base, so that one doesn't change. 7 squared is 49. The x is in the exponents. Drop your bases. You have 10 equals 2x, or x equals 5. I'm going to go over and look at, let's see, problem number 6. 3 and 243. Now, if I'm not sure what 243 is, I'm going to use the tip of 3. What would 3 raised to the 3rd power be? That's 27. 3 raised to the 4th power, 81. 3 raised to the 5th power is 243. So that'll be 3 to the 5th. 3 to the 5th is 243. And this 3 is okay, so that's 3 to the 2x plus 1. Now drop your bases. My equation is 2x plus 1 equals 5. This is linear, so move your constant over. 5 minus 1 would be 4. X will equal 2. Let's look at a problem such as number 8. We have a 2 and a 4, so 2 will be my base, 2 to the 3x plus 2. This 4 will be 2 squared. Now you notice that I have another exponent of x plus 2. So I've got to distribute, and you've got to go all the way through now with this exponent. So that'll be 2 to the 2x plus 4. Now drop your bases. You have 3x plus 2 equals 2x plus 4. We want our variables on one side, so 3x minus 2x would be x, and 4 minus 2 would be 2 for my answer. Alright, if we have a problem like number 9 with a fraction, you remember from the definition of an exponential equation, my base has to be positive, but it can't be a 1. So my potential base is 27 or 9. When I know I can't use either one of those, I'm going to go to a 3. So 27 becomes 3 to the third power with the x, and 1/9 becomes 1 over 3 squared. Now, here you have things kind of off stride. You want this 3 and this 3 to be in the same position. So what I'm going to do is to move this denominator up. Now remember, when you change positions with the numerator or denominator, the sign of the exponent changes. So that becomes 3 to the negative 2. Now drop your base 3. We have 3x equals negative 2, or x equals negative 2/3. Alright, we want to look at number 10, or maybe number 11. As you look at this, I'm looking at 3 bases, a 9, a 3, and a 9, and I have to get to one base on each side. That base is going to be a 3. So on the right side, I have 3 squared, that's 9, times, I'll use this same base, 3 to the 3x. This 9 has to become 3 squared with the x squared sitting there beside it. Now remember the rule that if you're multiplying with the same base, you actually add exponents. So that's 3 to the 2x squared plus 3x equals 3 squared. Now my bases are alike on each side. I drop them. I have 2x squared plus 3x equals 2. This is quadratic, so I'm going to bring everything to one side equals 0. I'm going to see if I can factor this. I'll have 2x times x. And let's try 1 times 2. Now this would be 4, which needs to be positive to give me 3 and a negative 1. If I set both of these equal to 0, I'll have x equals negative 2 and x equals 1/2. Okay. We'll try to get in this last one. I have a base of 4, I have a base of 2, and I have a base of 1. My base needs to be 2. Remember, the base can't be 1. So I'm going to use this 2 to the 7x. I'm going to say that that 4 becomes 2 squared, and keep the exponent x squared. This 1 is going to be 2 to the 0 power. Remember, anything with the 0 power is equal to 1. Now I'm multiplying with the same base, so I'm going to use one base and add my exponents. Then my bases are the same, so I'm going to drop them. I have 2x squared plus 7x equals 0. I'm going to remove my common factor of x. I'll have x equals 0. And then I'm going to have 2x equals negative 7, or x equals negative 7 over 2 for my two possibilities for my exponents.